Howdy everybody in YouTube land. What we have in front of us today is a big pile of Toshiba scrap. The T11, T1200 series style machines here. So this is, yeah, I don't know if I'm going to be able to get anything working out of this stack, but we shall try. So what we have is, I've got all of these miscellaneous cards. That's an old modem from something, just a random screw. But there's a power supply, and these things are just absolutely filthy and gross, nasty, and almost always not repairable. No surprise there. Got another modem card. These things are nice because I can always steal the connectors off of them and use them on a more modern card, like a PicoGus or a PicoMem or something like that. Unfortunately, there's only one guy that I saw who makes modern cards like this, and so I'd have to scrap those to make them anyways. So, yeah, all of our little mounting brackets. So, the problem right away is I know some of this stuff is going to be scrap because, for example, this panel has vinegar syndrome and it has screen cancer. So, that's garbage. We've got an interface card. We've got all of these batteries. These are NiCad. These are the standby batteries and all that other stuff. So we don't need those. I don't even know if they make these stick batteries anymore. So we'll keep the connectors, of course, but that's assuming they're not corroded up, which that depends. No, these aren't. So I can probably keep those old JST connectors for replacement batteries if necessary, but I doubt that I'll need those. We have our bezels. Nothing crazy or spectacular going on here whatsoever. As our 16-bit ISA slot style connector, we have our floppy drive. So hey, we have a spare floppy, maybe. I don't know what we got going on underneath this thing. Yeah, well, we have the logic board. Oh, crap. There's that screwball 3824 JVC drive that they're almost always bad. Another battery. They're almost always bad. I have not encountered one yet, personally. Doesn't mean that they don't exist. I'm sure they do. But they don't exist in my domain. Because I've not encountered one personally where that drive actually worked. And I've got a whole stack of them now. So that's unfortunate, but that is what it is. So, well, we have a logic board at least. And then we don't have a keyboard. And then we have a whole nother machine up under that, but I don't know what it's all missing yet. So, actually, let me get that out of the way. Because I don't know what we have going on here. So this is another T1200. I don't know the condition of the screen. Hey, this one has the keyboard at least. Oh, God. Screen's in decent shape. I don't see any signs of vinegar syndrome yet. This is the backlit screen, unlike that one. Keyboard works. Well, sounds good. So we have a functional keyboard with that one. And this one is in relatively decent condition. I don't know if there's any cracks or anything like that. I don't see them. No. The rear. Yeah, you could see. Ooh, yeah. This one leaked so bad you can see it through the... Smells like cap juice too. So, another modem. So we got plenty of cards to make new cards out of, but yeah, let's get all the scrap out of the way and get this one apart to see how bad this one is. Fortunately, it's as easy as taking all the screws out of the bottom and then the two up here under the battery, kicking it off to the side here while pulling this cable, but there's still a little wire left in there. So I have to get this keyboard assembly out. Yeah, it's not too bad. Yeah, that's pretty straightforward. We'll get this keyboard out because I don't need the keyboard to do what I need to do next. Ease you out of the way, which that's a keyboard. Kind of good. Oh, yeah, this was... I found some bugs in the code, or at least bugs in the hardware. Yummy. Found some bugs in the hardware. Damn. Anywho, this allows us to get that out of the way, which is a very weird connector. I don't know why it's... Anyways. Okay. Get you out of the way. So that reveals all of this craziness down here. Now, if we take a closer look, this board is absolutely disgusting. As expected for Toshiba of this era. Yeah, and the problem is this thing will probably not come up very good either. I can see why there's an open source version of this project because this is terrible. So we got to disassemble all of this down bare minimum just to see what we can get to. Now, the hard drive is another one of those basket cases because there is a bunch of surface mount caps that leak on those. So getting that working is probably going to be next to no. But it is what it is. Because I've tried to get those fixed. And you got to remove the head and platter assembly to get to that. And when you do that, you lose the alignment. That's the big problem. So, yeah. Our more immediate concern is that board. So we need to get that out of here. Moving all the plastic crap out of the way and shoved it over there. That reveals the motherboard. Now, one thing I noticed is that 8086 chip looks like it has been reworked, which is kind of interesting to see. But other than that, it looks pretty bog standard for Toshiba. They're using all of their custom gate arrays like normal. Keyboard controllers over here, the 8049. There's a RAM expansion card under there. There's 8 256 K-bit chips. So, but I don't know if they're K-bit into 4 or K-bit into 1. Don't know. I think this is like a 1 meg expansion, but I could be wrong. Not sure. There's the hard disk controller. It appears to be 100% proprietary, as expected, just like the THEtechknight series. They've done something weird with that. You could use this as a XT IDE expansion, but the problem is the IO select or the chip select lines are pretty specific to this machine. So you'd have to patch out the ROM with an XT IDE ROM. I don't know how that would work, but I don't know. That's a thing for another time. But this whole setup would have to be removed if we're going to use an XT IDE on one of these little cards that go in here, because I almost guarantee you this is not going to work. But hey, I've been wrong before. I could always be wrong again, but I have my suspicions. Anywho, the important thing that I wanted to take a look at was this power supply, because this power supply, just like every other Toshiba, does not want to come out of that stupid JST connector, is kind of not very good. So let me move that out of the way for right now. I'm running out of space. So, yeah, it's not terrible, but it's not good either. Like, if we take a look closer to here, chances are those traces are gone. Just about guarantee you. And we have another power supply here to take a look at as well. Well, we know that is an A4 because that one is readable. That one is not. A lot of this isn't readable. Yeah, this is quite terrible, actually. This one's not that great either. This one's even worse. This one's even worse compared to that one. This one at least looks salvageable. I could probably fix this one. That one, no, that's not going to happen. It's these stupid Elno long lives. They're horrible. 1810 volt. I doubt I'm going to have those on hand, but I may. I probably don't, but I might. Alright, well, best thing to do, honestly, is get a capacitor list together for this thing and try to wash this board. Get all these caps off of here because that is disgusting. Alright, I've been over this board for a little while now, and it's actually not that bad. So, yeah, there's a bunch of corroded traces in here. But I buzzed all of these out, and they're all okay. So I did the same thing on the bottom side, and I found one right here. That one's open. And it's open right where it goes into this transistor right there. Let me zoom in. So you can't tell easily, but right here where it goes in is open. So this one is broken. I got to fix that one. But the rest are okay. There's even some dodgy ones down here. Like there's one there. There's one that comes across that way and a few others. This drives one of the converters. These 3 transistors. Because there's the inductor up on the other side there. So that drives one of the converters. So this has to be good, or we're going to lose one of the 4 voltages. But aside from that, it seems to be alright. I'm not seeing anything. So the only one that's open that I see is right here. And that runs one of these three transistors over here. So we got to fix that. Aside from that, that's all I have. I don't really have anything else to report on that. So I might have gotten unscathed compared to like this one over here, which is really bad. So I got to look through here to see if any of these transistors are salvageable. I don't think they are. But, oh yeah, that's another thing. 2 of these transistors are bad. And one of them visibly, so the other one's leaky, but one of these is actually visibly bad. Trying to figure out which one that one was. It wasn't that one. It was this one. You can kind of see where it's bulged out the rear a little. It's where it's fried. So someone tried to turn this on and run it like that. So that one died. I don't know what the collateral damage is yet. Because usually when you lose a transistor, you take out the regulators along with it. Now, these 1451s are jelly bean. These were really common back then. So, if one of these 2 is dead, it's not a big deal. I can replace it, but I'd rather it not be, of course. Anyways, I gotta go through my bin and see if I got some caps. This is what we have as far as the capacitors are concerned. There's a very oddball value there. Closest I have is going to be a 220. But the rest of this, pretty much off the shelf. So all the caps are installed now. I've got that one little trace patched right there. So when I could visibly or see. There could be more, I don't know. Also, I went ahead and put in replacement transistors. I've used the 5410. Like I've used in other designs. I don't know if that will work with this design. They're also EOL, so I made sure to get a few of those while I could. We'll have to see how it works, so let's get this thing in there and see what happens. Alright, it's now or never. Also, this is one of those machines that will not run without the battery installed. So here we go. We're going to ground you there, following the symbols. Ground you there. Okay. Nope. I suspected. Oop. Wait, it's on. And then it errored. Hey, it ran for a little bit. And then it shuts down. I mean, it's trying to run. I don't know what the battery voltage is supposed to be. I got it set to 7.5 volts. Okay, 7.2. All right, let's dial you down. 7 point. Close enough. Turn that off. I don't know. Then it shuts down. So I don't know. Let's see. Power. Okay, hard disk drive. All right, hard disk drive off. Power off. Okay, doesn't like that at all. Yeah, I'm trying to figure out how this thing works. It's not exactly straightforward, but it is trying to run. So that's a good thing. I finally figured this thing out. So right now it's running by itself. Well, kind of. So right here is a SOT89, I think. That is a 5-volt low dropout regulator, and that one was pretty corroded. What that does is that provides 5 volts out of pin 6 here, which powers the RAM and a few other little critical components meant for standby. There's a big standby battery that connects right there, which feeds that regulator as well as the regular power supply. So what's happening is it's idling at about 4.5 volts, which is already fairly low for CMOS circuitry. But then when you go to turn it on, I can't do it on camera while holding the camera. You go to turn it on and you press the power button or the switch, this thing will fall down to like below 3 volts, sometimes 2.5, and that shuts it down. It'll never run, even with the battery attached. So I think what we have here is a bad regulator, because what I've done is I've injected 5 volts straight from this second power supply, and it's running. It's on. It's idling. It's happy. It's working perfectly fine. That's what we got going on here. That's what I think anyways. Now, it is possible this thing needs a good standby battery. This design requires a good standby battery. I don't know. I don't have one. But that clearly is an issue, because this regulator, even the input voltage, it's only falling down to about as high as 5.8, which is low, which means this thing is a low dropout regulator. So you got to have a low dropout regulator here. So I'm thinking what I'm going to probably do is see if I can't substitute something in there, because finding that's going to be fun. All right, one thing I want to test is I want to test where my dropout point is. This may not be accurate because I'm back feeding 5 volts into the BRAM situation. Let's see, I'm going to drop this down to 7 volts. I want to see which point this thing will trip out. Oh, tripped out at exactly 7 volts. So we've got it's a little bit low in my opinion. I think it's a 7.2 volt battery, so the fact that it trips out that low has me relatively concerned. Anyways, so we've got to turn the power off, turn it back on. Nope, not helping. So we got to leave it off for a second. And does it turn on? Yes, it's working. It's going into reset, and we have a power light. So the machine is running. The battery set point seems a little low. Nope, we're good there. So the battery set point seems a little bit low for some reason. It shouldn't trip out at 7 volts, but it does. That's assuming that is accurate. I don't actually know. I need to check that. Is that accurate? Nah, about 7.5 volts. So, yeah, that has me relatively concerned. But that's good. That's just small meat and potatoes. And I bet if I drop that voltage off, this thing will trip out. In fact, let's lower it. Bam. Yep. That's how I know the low dropout regulator is bad. So that's what we got. We got a bad low dropout regulator. I suppose the hardest part is trying to find out what regulator this is. So it has an SMD code of RD. Now, if we do a quick Google search, we find the data sheet, which is the S802 812 series. This one in particular is the 81250. So, trying to figure out what the voltage differential, let's see, 81250, 30 millivolts. That is an extremely, extremely low dropout. So, if we look at the data sheet, we have our pinout, and it pretty much matches what I saw on the circuit board. And if I go into our Mauser cart to try to find something, the input voltage differential only goes down to about 300 millivolts. They don't even make anything that anymore. Dropout voltage. Well, we're running, let's see, 25 milliamp. I don't know. Let's apply the filter. 25 millivolt. I mean, low supply regulator 80 millivolts. Input voltage minimum 5.5, which is weird. So that's actually 500 millivolt, with our dropout voltage being 25. So this is the closest we're going to find. If we pull a data sheet, do we have the right pinout? Dropout voltage 40 millivolts, so that's about right. SOT 89. There's our block diagram. Let's see, what do we have? SOT 89, 1, 2, and 3. Ground, 2 is input, and 3 is output. So 1 is ground, 3 is output. And if we look at our diagram, or circuit here, pin 1 is definitely ground. So if we rotate it across, so we have our ground, we have our input, and we have our output. So yeah, that's correct. All right, well, we have a candidate. We have a candidate. So let me, it's $1 a piece though. Ugh. Let me just grab a couple of them, because I find these, this is like the second one I've found bad. And actually, I got a T1200 XE that's been circling the runway for 2 years now, which may have a bad one of those. So I'd like to grab a couple of those just to have them on hand. I've already got other things in the cart. The other thing I could do is potentially look on eBay for this part, but we'll see. So I found this particular one on Mauser. It's the only thing modern in current production that has even anything remotely close to the specs that the original had, and it's still not quite the same. It's close, but the other one has almost 30 millivolts delta regulation, which is impressive. This one doesn't even have anything close to that. I think it's 60 millivolt with a minimum rated of 5.5 volts, which is, well, we're going to give it a shot. I have the original ones on order, but they've been long since out of production, and you can only get the aftermarket, new old stock, or whatever. So hopefully those will be good. But I wanted to do this just out of curiosity and experimentation, which will give someone options going forward, because at least these are still available. But because I spent so much time hyperfixated on that, I forgot the 100 nanofarad caps. I don't have any. So the closest thing I got is a 470. So will it work? I don't know, but we're going to give it a shot. So let's get these components in here. I pulled the filter choke out of the way. It's only used for the input anyways, and I'm going to use the battery jack. We're going to go ahead and get that in there, and hopefully that fixes our problem. But it's no guarantee, because again, this isn't the exact right one, but we'll see how critical it is here in a minute. All right, well, we have the component reinstalled. Well, those two components anyways. So it's now or never. Does it work or does it not? So, does it stay on? Here we go. So far, so good. It's on. Holy crap, it's running. Alright, let me go grab the screen and plug the screen in. Let me turn the power off. Should go off. It does. Let's go grab the screen and just kind of shove it in here real quick, which I think the screen is right here. Sit on the floor. Now, FYI, this is a parts screen. This screen will never be used because I have two of these machines and one of them was missing things and beyond repair. So between the two of them, my goal was to make one working one. All right, here we go. Let's see if it turns on. Yes, it does. Oh man, that is a hallelujah moment. Wow, I actually got the original power supply fixed for this thing. There's still more work to do because I have voltage sag for the 12 volts across that MOSFET, so I think that channel is leaky. So I'm going to have to pull that MOSFET out and double check it because when this hard drive tries to kick on, the 12 volts falls down pretty harshly. But on the input side, the 12 volts is solid, so I know it's that MOSFET because you only have these two resistors in between and a LM339 on the other side. So there's really nothing in between. Anywho, yeah, it's working. So I'm going to let this run for a bit and make sure it's going to continue to work. But I think it is. Now that we put the most difficult part to rest, for now, where do we go from here? Well, got to pull that out just to make sure we're okay. But besides that point, this display is a parts display. It's not going to be used. Doesn't matter. I got to take the original panel apart because there is an EL backlight inverter in there that also has capacitors that leak. So I'm going to get that apart next so we can take a look inside to see what's going on as soon as I get this transistor checked out and or replaced. Actually, I pulled it out and it's fine. The junction has no leakage. So there's nothing wrong with that transistor. So that tells me that our problem is more likely the hard drive itself. It's the same problem I have with every single one of those 3824 JVC drives. I bet the platter is seized, so it's just consuming way too much current. That's a guess anyways. There's the top cover with the correct screen. Now, unfortunately, this one has got a nasty crack in it, so I'm gonna inspect the other one. If it's in better shape, I'm going to swap the two. I don't know how I'm going to do it yet. I think the way that works is we just remove all of this out of here. I don't know. Also, the problem with these early Toshibas is every single one of these requires you to run them off of the battery. So we're going to have to either rebuild or substitute the battery, which is why the aftermarket power supply design that people have come up with is better in that regard because it'll just power straight up. You just lose all of the ACPI features. So if you want this thing to be portable, then you're not going to get that, unfortunately, with the aftermarket power supplies. Unless you use like an external USB-C charger and you design the power supply to run off of USB-C, which would actually be kind of fun. But beside that point, yeah, let's get this thing apart. These guys are a little bit tricky to get off. You got to take that sticker off, which almost always ruins it, to get the screw out so you can slide this thing down, and it doesn't really want to let loose up here, but it has to slide down and then off, which will remove the cover. Now, I'm thinking once I take these 4 screws out, the inverter for the backlight is hidden behind here because I don't see it anywhere else. So let's confirm that theory. What's behind door number 1? Yep, that pretty much confirms my suspicion. So our Power supply is right there. So now I got to get all of this disconnected so I can get this out. Now there's some caps here that might need attention. Because once I get this thing done, I do not want to get back in here again. So, yeah. Alright, well, let's get that out of there. Looks like the only thing holding it in is 3 nuts, so that shouldn't be too difficult. Yeah, that is disgusting. Once again, more leaky capacitors. So, and the only thing I don't like about caps is they eat the screen print. So, that one I can still see what it is, but this one I can't. So I'm going to do my best to try to read what that is before I clean it, because chances are, once I do so, we're not going to know what that was. And we may need to replace it. So I don't know. We'll see. But yeah, that is rough. You can even see it got on the plastic film here. These are going to be a problem eventually. And that is something really weird and proprietary. It's getting sticky too. Yeah. God. Age. 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 I caught what looks like maybe a 3 or a 5. 93p. So 393. But I tried to wipe it off to get a clean view and it's gone. You can't see anything there anymore. So pretty sure that's an LM393. Anyways, this thing is gross. Got a pair of 10 at 470s. I'm going to cut those out of there. Those are disgusting. Blech. Actually, in just the right light, which the camera is not. Yeah, you can. That is a TA75393P. You can just barely read it. I'll have to Google that. Yeah, TA75393P. Yep. Now, there we go. I went ahead and washed this board off too. I gotta get all this off. This foam is starting to rot. Before I work on the backlight module, I want to make positively sure that this screen works fine without any problems. So what we're gonna do is just quickly set it in there and see what happens. So we're gonna turn this on. And we'll turn the power on. Make sure this screen works. Which it doesn't look like it does. No. That is a no. But it may not be compatible with this motherboard either. So, let me see here. Let me press this reset button on the side. No, doesn't really work. Nope. Alright, well, let me grab the other motherboard, because this motherboard is not working with this screen for some reason. So we need to figure out why that is. So let me go grab the other board. Alright, so. Okay, screen's on the other motherboard now. So let's test the motherboard that went with this screen. Yeah, that's not good. Well, contrast control's working. But that's bad. The screen's bad. Yep, we have a bad screen. Motherboard works. Yep. That sucks. So we've got a bad screen. So all of this work for a bad screen. You've got to be kidding me. Turn the power off. So that's unfortunate. So, yikes. Alright. Well, that sucks. Where do we go from here? That's a good question. Alright, so here's what I've done. I put the crappy screen on the backlit chassis wiring harness here. I want to see what this does. Huh, same thing. Same exact thing. Because I measured wire for wire, it goes through there. I don't know. There's this extra wire the other harness doesn't have. So, besides the glass, the actual circuit boards are the same. Because you can kind of tell that. So, oh god. All right, well, the wiring harness is not working. I wonder if with this not plugged in, does it complete a path? I don't think so. Then again, it's hard to say. This goes to the brightness adjustment. That goes to the wiring harness. So I'm curious. That one goes off to that controller over here. The pin number 3 doesn't go to anything. So there shouldn't be, let's see here. I'll make sure it's nothing coming through there. No. No. There should be no reason why this wiring harness isn't working unless there's a break in this harness. Which is entirely possible that there's a break in this harness. Alright, so here's what I'm going to do then, if that's the case. I'm going to grab the other one. Set that one aside for right now. We're going to grab this one, because this is the screen that went to the upper bezel that went to the crappy one. I'm going to put this panel in here and see if this panel comes alive. Because it looks to be about the same design. Alright. Backlit display in the non-backlit harness. Let's see what that does. Hey, what do you know? The screen's good, although we do have signs of screen cancer developing. Other than that, it's not in the viewable area, so I think we're fine. So, our problem is, everything looks great on the screen. Let me get a light. Let me shed some light on the situation here. Yeah. Yeah. Alright, so there's something up with that harness. Now, this harness doesn't have that extra wire which plugs down into like PJ19 right there, which is the next one to the green jack. Okay, so that might be what our problem is. I'm starting to suspect this completes a circuit. Without that installed, the screen doesn't work. So let me go ahead and get that thing fixed and get it reinstalled, considering I know the screen is good anyways. Alright, so went ahead and replaced these 3 here that needed to be changed. And then, but even though these didn't show any signs of leakage, I went ahead and changed these as well. These are 10 microfarad at 25 volt. Those have been replaced with brand new Panasonic caps. This one's been replaced, which is a 33 at 25, and then these are 470s at 10, which all I have are 470s at 25. So that is what went in there. I cleaned all the old foam tape off that was disintegrating, so I'm going to go ahead and get this thing cleaned up and reassembled. Alright, so let's turn it on and see if we have the screen now that everything is connected. Hey, we do. Awesome. So yeah, the inverter has to be in there to complete the circuit. Let's see if the inverter is on. Oh yeah, it is. But oh wow, that is shot. Look at all this. So the EL sheet is very, very dim. The camera is making it brighter than it really is. But you could see damage in it. So I'm starting to wonder if I shouldn't replace that sheet with something. I don't know if I have one. I might have something I can cut down. I have a T1200 XE cracked LCD, which if the sheet's any good, I could pull it out and use that. But you know what, though? It's working. This is impressive. It's actually working, though. This is a lot further than where a lot of these machines are, especially with their original power supplies. So not only is it working, but it's working with the original power supply. You can't beat that. Alright, maybe the third time's a charm with these drives. So here's the next thing I want to do. I want to see if I can get this drive to spin before I do anything further with it, and if it'll initialize. So we're going to turn the power on. I got the drive power turned on. Let's see what happens. I think I've had this issue before, where these things just do not want to spin. No, it trips out the power supply. It's like, no, we're not doing this. No, it's not. It's not really wanting to go. I bet you I can get it to spin by doing like I did the other one in the past. No, maybe not. Yeah, that is so weird. These drives will just do that. So here is why none of these drives are repairable. One is because the circuit board is double-sided and it's part of the drive enclosure. And because of that, they have this big filter thing in here. In order to get that out, you have to remove the platter, which I sat over there. Doesn't matter, it's junk anyways. So, because they hide leaking electrolytic capacitors under the platter. Now, here's the issue. So, this is a stepper-based drive, but also, just like a floppy disk, there's an index pulse that marks the beginning of the track. Okay? Well, on these MFM style drives or RLL drives, that indexing pulse is referenced by here. So not only is this your tachometer, this is your index pulse. So the minute you remove the platter, regardless, this moves it at all, that's it. It's done. There's no way to get your data back because now your index pulse is going to be out of alignment. It's the same thing with 3.5 inch floppy disks. When the little hub gets loose from the internal, what they call the cookie, and you try to glue it back in, it won't read anymore. You have to reformat the disk. Fortunately, you can reformat the disk and you're off to the races. These, you can't, because there's low-level crap stored on the platter that this drive needs to be able to read to become ready. So it will spin and try to initialize and fail because it can't read those tracks anymore. So none of these JVC drives are ever going to be repairable unless you figure out a way to reverse engineer the firmware on these drives and rewrite those tracks and reformat it with new index pulses. It's just the sad reality of these drives. So none of these are ever going to be repairable. Just putting that out there. Alright, this is my last hard drive. Maybe the fourth time's a charm. No spinny. Oh, there it goes. Is it going to actually work? Are you serious? Holy hell. Holy hell. The hard drive is actually working. And it's got Toshiba T1200 on it. What's on it? Nothing. Just hello and JVC. Is there anything in that folder? Nope. The original drive is working. It's not going to work for long because of the leaky capacitors, but the fact that it actually works is impressive. Yeah. That's wow. I I'm lost for words. This is the one hard drive out of like 6 of these that I've worked on over the last 2 years that actually works. Out of 6 of them. The other one was dead, wouldn't spin up. The one I just tore apart. Uh, couldn't get it to spin, so I got rid of it. And then this one spins, but look, leaky capacitor disease. So I'm gonna have to take this thing apart, and I'm gonna have to change the caps on the other side, but I can't do it. Ah, man, the platter is in the way, and I can't remove that platter, or I'm gonna have serious problems. Ugh, decisions. So I'm at a crossroads because that is my only working drive out of all of the drives I've owned so far. And the issue is you can't get, here's the problem. So this is the other drive that I took apart, which now no longer works because I took it apart. There's 3 capacitors under there you need to get to, but you can't do that without removing the platter that I can see. So, and there's the air filter thing that's under there that has to be removed. So the problem is, what I have to do, which I didn't do to this drive, is I'm probably going to have to mark everything before I move the platter and try to get as precise as I possibly can to get it back in. This one I didn't mark, but I marked after the fact so I can see where my position is. And I got it to where it kind of will try to read now, but it also won't. It throws missing operating system. But if I move it ever so slightly out, it just says non-system disk or disk error, and it just clicks. So unfortunately, this particular MFM drive, if you look on the spindle here, like I said earlier, there's that little black dot. That's the indexing pulse for the Hall sensor on the spindle, which I guess the drive's firmware uses a reference to lay out the index track on this. So if any of that is out of alignment, you're screwed. So this drive does work. Do I just put it back in there and leave it? Or do I attempt to repair it, take the platter out, put the platter back in with alignment marks, and hope for the best? It's a 20 meg drive, so it's not like it's super precise, but it's precise enough. Yeah, I mean, just for the sake of experimentation, I honestly think I should do that anyways, because these drives aren't going to last very long, regardless. Most of them are dead. This one was seized, and I had to free it up. Alright, let's just do that and see where we're going to get with it, because there's nothing important on that drive anyways. How it's going to work, but my thought process is, this is the junk one, is to pull the hub and make some timing marks on the platter. You know, just obviously wedge the head, make some timing marks on the platter before I actually move it and get it out of the way. So that way I can get to these 3 caps that are on the bottom, because otherwise you can't get to those. And you have to pull, once you pull the platter, you have to pull the filter out, and then this is a silly design. But that's how it's designed, and I can't change that. Alright, well, it's junk now. When I tried to get this nut off, my little pliers thing slipped and gouged the platter. So I'm like, you know what? Heck with it. Hey, you know what? It is what it is. You live and learn with this old crap. So the problem is I don't know what to do about that. I guess I'm going to have to make an expansion card or get an expansion card to solve this problem. Because even if the drive still worked and I didn't screw it up, you can't get to those caps. You have to pull the platter out to do it. How do you retain the alignment? Because this isn't a stepper drive. Even though it kind of looks like a stepper drive, it's not. It's coil actuated. So, yeah. So, out of 5 of those drives, maybe 6, I don't even know exactly the count, between 3 different computers, 4 actually. There's footage I never uploaded, but there's like 4 different computers, 6 of those drives. I had one that worked. One. And I fucked it up because I got nervous and I dropped the tool on the platter. But there is a way to redeem this situation. Sort of. Well, like I said, we've got two of these computers, and one of them's a parts machine because of the LCD being so bad. Let me grab my thing over here. So we have the original floppy drive and hard drive bracket thing for this computer. But also, we have... Let's grab it too. We have another one for the other computer. So what I'm thinking about doing, since the hard drive is proprietary, everything's proprietary in there, there's no sense of even putting another hard drive in there because you can't. Well, you can, but I'll get that in a minute. So I'm thinking perhaps I can redeem this situation by filling that void with another floppy drive so we can do a 2 floppy drive setup because we have 2 ports. Why not? But the other thing too is this machine has one of those expansion slots on it, unlike a lot of these earlier Toshibas. So I could actually put in an expansion card in here that has IDE on the card. One of those XT IDE adapters. Or a Pico Gus or Pico Mem that has IDE storage capabilities built into it, along with any 2000 wireless emulation, which would be a lot better for something like this. So, and more reliable. So I think that's what we're going to do. I'm going to take these 2 floppy drives apart. I'm going to service them, check for caps, change any necessary caps, whatever. And we're going to reassemble this machine with the 2 floppy drives, because why not? We got a void to fill. Well, taking the drive out, and upon first observation, I don't see any leaky caps. At least not on the motherboard here. So I decided to drop loose this one, and it's the same thing. I don't see anything in here that I need to worry about. So I'm probably going to just do a little bit of light service with this drive. And just put it together and check this one out, because this one's slightly different. So the conversation I had a little bit earlier about the index pulse on those hard drives, I want to actually show you something on these floppy drives too. So here's an example. You see the hull sensor, there's a magnet there, right? That is the hull point. Well, notice with the hull sensor activated, we have an alignment mark right there, which is in line with the read-write head. If we flip it over, you're not going to be able to see it. But if I open up the flapper to the drive, I'll zoom in here a little bit. There's a little peg on the spindle there. You can't see it, but there's a little peg on the spindle that is directly in line with the head. So that just tells you how critical the alignment of all this stuff is, because when we're passing the index pulse mark, we're perfectly aligned with the head on the little disc hub spindle thing. So it's important. So the alignment has to be on, or you're not going to be able to read any discs. I find it interesting. Both of these computers are the same, except one has a backlit screen, one's not. But yet the floppy drives are completely different. And, I mean, they're the same interface, but like this one here, like this one we already took a look at and I did some light greasing, but this one is even different. And you can see the hull sensor's in the same spot. One of the difference though is the magnet is in line with the hub timing hole. And I wonder, I don't know, we'll see. Caps are different as well. The whole motor driver is different. But once again, we're going to take a look, see if we see anything leaking, any evidence of it, and I do not. So I'm probably going to leave it alone. Got to pop the cover off, do some light greasing, and I got to pop this out and take a look in this too to see if there's anything of any importance. Don't think so, but we're going to find out. Alright, this one you can see a little better. So if we take, and again, if we line the magnet up right here where the hull sensor is, wherever that hull sensor position is, you can see, look at that. See the peg? It's right there in alignment with the head. So there you go. If you ever have to take the spindles off on these floppy drives, you got to make sure the peg is in alignment with the head, because that is your index pulse. The index pulse, because just like hard drives, floppy drives, you have your track-to-track alignment, you have your track zero alignment. So your track-to-track is your vertical alignment, right? And then you got your horizontal alignment as well, which is where your index pulse is, the start of a track. That is what indicates the start of your track. And to save disk space, the start is not recorded on the disk. I don't think it's using that. But I could be wrong. I don't know. But that's why if the hub ever comes loose on your floppy disk and you need to glue it down, it won't read anymore. You have to reformat it. So, yeah. Anyways, do some light Q-tip, clean that up, do some light grease, and then put it back together. Because I don't see any caps on here that are any important. Maybe I should check this board here, but it's not easily coming out. Nope, that won't work either, because it looks like it needs a special bracket, which I don't have. I don't know what would have been there to be able to even replicate it into like 3D print file or something, because nope, that is not gonna work. Crap. Well, so much for that idea. I mean, I might revisit it in the future, but that future ain't gonna be now. Actually thinking about it, the alignment is on this side of the drives. So I'm gonna go test fit this real quick, because I think all I need is a shim over here and some longer screws. So I might be able to measure this off and just make a little rectangle in Tinkercad and just print it off and use longer screws here. It actually fits pretty good. Everything looks fine from the outside, so I'm not going to see a problem here. I do gotta, well, almost. I mean, there's a little bit of a gap, but I don't know. We'll see. Biggest issue, though, is dealing with these cables. There's just not enough room to cram all this in here. However, if we look on the bottom, there's enough room underneath the drive where I could fold the cable this way and snake it back. I might be able to do that, but I still don't know if it's going to work, because I've run into this problem before where Toshiba's in particular, I can plug both drives in, but only one's ever seen. And then when you go to the B drive, it'll switch and use the A drive as the B drive. And I know there's a switch on the side where you can switch it, A, B disabled. So the problem is there's no jumper that I can see on the drive that sets the select line. And these also follow what became the 26-pin Citizen standard that every laptop used up until the end. So that much I know, but it fits. Now, the other thing I need to swap these bottom covers around, because this bottom cover, the handle isn't broken. It's starting to go, you can see, but the other one is cracked and broken, so the handle won't stay up where this one does. So I need to switch the bottom covers. But I need to switch the boards too, because the problem with this one is, this board has, even though this board works fine, this cable has got capacitor damage, and it wicked its way all the way to the board, and it corroded the board down here, where mine doesn't, or the other one doesn't have that problem. I keep saying mine. This one wasn't mine at one time, and it was given to me. But yeah, it's wicked its way all the way down into here. See that? And it's damaged that stuff. So I need to make sure, yeah. The other one doesn't have that problem, so I'm going to swap all of that around. This board does run, though. So I know I can put this board up in my parts box and say, hey, it's good. But I'm going to swap all of that around. And thanks to the magic of 3D printing, we have a shim. So in theory, it should just slide right in there. Line it up like such, and there we go. Holes line up, everything lines up. There we go. All I got to do is find some longer screws and then screw it in, and it should hold itself together. It looks pretty good. No problem there. That's a lot better. We're together now for the most part. I still got to put a screw in here, but there we are. Double floppy drive. It's a little bit ridiculous, but you know what? It's a good way to fill a void. Still don't know if it works though. We got to figure that out. But we're getting there. Right, so we are up and running and booted now. So I've got my A drive on the top here, which I can actually see that drive. Everything's working. So I'm going to put this high density disk in the B, see if we get B drive activity, and we do. And it looks like that does not support high density disks. So let's try our double density disk here. Retry. Yeah, that's what I thought. Yep, it's fine. So, okay. Alright, well, we know that that works. I don't know if Norton Disk Doctor will run on this thing or not. It might. We'll see. Yeah, it does. Alright, well, we want to get out of this thing, so, because it's not really good. But, alright, so this machine can only work on 720K disks. So that's alright, but at least we have 2 drives now, so we can do dual 720K systems. Now, I don't know if this thing will run on the battery or not. Let's see. It looks like it's on the battery. Oops. I took the disc out. So this thing's running on the battery. Now I can shut it off. Alright, so this thing is actually running on battery. I'm impressed that the battery is even holding a charge. It probably won't hold a charge long. A couple minutes at max. But it's running on the battery. So, nice. Alright, what's next? Well, this keyboard really needs some serious attention. It's absolutely filthy. If we take a look at it, you can kind of see how gross it is. So I kind of want to get this keyboard. Look at the key. Ugh. I kind of want to get the key switches off this keyboard and get them in a cleaning agent, because this is nasty. Well, all of the keys are in my alphabet soup over here. Anywho, I have noticed the key switches on this thing are rather unique looking. I've never seen these before. They're all Alps, because you can see the Alps, and it's the same as Alpine. Alp and Alpines was the same company at one time. I don't know if they still are, but they were. So the same company that made your head unit in your cars are the same company that made these key switches. But this is a very interesting design. I've not seen these key switch designs before. Oh yeah, that looks so much better. No dirt or anything on it. It feels much nicer to type on. And also, I got the CMOS battery hooked up. You can't see it, but well, actually I might be able to lift the keyboard up without damaging anything. There's a diode. No, you can't really see it. Well, there's a diode in series, because the original CMOS battery was, rechargeable, so we're not doing that. So we put a diode in there, because the original battery is 2.4 volts. This is 3 volts, 0.6 volt, 0.5 volt drop across the diode. I think we'll be all right. I don't know how long it's going to last, but this is the best way to get it out of the way, so you could lift it up, get the battery, and, or something like that. So the only thing I don't have is I don't have the standby battery in here. That doesn't matter. This backs up the hard RAM anyways, which this machine will not typically use, because it would have a hard drive, which is now dead. Beside that point, I think we're in a good spot to start getting this thing back together. Would you look at that? That is beautiful. It's running, it's got the battery in it. It won't hold a charge. It'll run for about 15 seconds and shut off. Um, got both floppy drives working, and all of them are visible in this machine. I can put both drives in there. I can do a, let's see. I don't think that has setup on it, so no. I gotta swap out that disk. Man, the B light works too. So yeah, they're set up on. So we got to go in here and perform the actual setup procedure, because the issue is, this particular machine does not use the parallel port in bidirectional mode by default. So we need to go in here and set this up. So we want to change the setup. We want to do manual. We're going to do 2 drives, built-in modem, disable, power on, resume. I don't know. Primary display, monochrome. We're going to leave that. Printer port, enable, low battery alarm, system speaker, built-in expanded memory. That's whatever. We're not going to do hard RAM or anything like that. Although we could. We're not going to. And then we're going to set data and quit. Yes. There we go. I still got to find a new EL sheet, because this is very, very dim. This is almost not even visible. So that's why I'm not going to put this back on until I get that replaced. So in order to do that, I have to find something. Yeah, we don't have Palm Zip because we don't have the zip drive connected, but yeah, everything's good. So this drive, I think, is just our default drive. Yeah, this is the IBM personal computer DOS. So we're going to pull that out, and we're going to move that disk up into the top drive, and then Control-Alt-Delete it, which is going to be, I can't do it single-handedly. So we're going to do it both hands. Reboot. It should boot that one, which I think is the Toshiba diagnostic diskette, which you can download online. I think. Is it working? I can't tell. Yep, there it is. 9/21/1989, which I know is not right. So we're going to go 07 25 2025. Whoops. We'll leave everything to Dell. There, now let's see. That's the IBM. Actually, no, that's the IBM personal system DOS thing. Okay. It's IBM, I guess. I was wrong. I must have made a mixed disk. Yeah, that's the one I just booted from. Let's try this one. I forget. They're all like mixed up because there's no labels. Yeah, that's it. That's the one. I think that's the same program. I think. Nope, it's not. No, this is the T1000 SE disk. So once again, reboot. Because the T1000 SE has ROM-DOS, and I just made a floppy disk copy of the ROM-DOS, which is what this actually is. So it looks like we've got a functional system. And it should show the correct date. And I'm going to take the batteries out and make sure it holds. So I am going to do that here now. Alright, I've had this thing plugged in for a bit this morning, but I also had it off all night long, so hopefully it has retained the clock information. We'll see. Well, it's not throwing a configuration error, so that's a good thing. We're going to get this thing to start up off of the disk. I don't know which disk I put in there. we're gonna find out. All right, that's my zip drive boot disk. Let's see if it held the time. Yep, it did. It's the 26th of July. So the battery is holding a charge. Everything's going, it's working fine. Oh, and we're running on battery. Look, Ma, no wires. That's so cool. It's not going to last. That battery is about done, but so I'm going to go ahead and shut that off now. And that's it. This machine is fully working. Now, I have to come up with a storage solution for that because of the hard drive situation. So I have the, like this little modem card right here that I'm going to use as a template. So, but I'm going to cover more of that in the next video. Because this video is getting rather long anyways. So I wanted to focus on primarily getting this thing working. And in the next video, we're going to get the EL backlight replaced. And also, we're going to get this storage card or modem card into a storage card. I'm trying to figure out what to do about this because the problem is there is one project out there called the 3-in Wonder, which is a compact flash, Ethernet, OPL2. It's a nice card. The problem is it's not open source. So I can't make one. And the other problem is it's overseas. So you got to deal with shipping and tariffs and all that nonsense now. So it's not really an option. Well, let me rephrase that. It is partially open source. Like some of the schematic is published, but none of the hardware layout, none of the dimensions, the 3D print files, the part number for this socket, none of that stuff's published. It's just not. It's unfortunate. But the other thing too, it's like I want to also take this card, instead of doing something like that, I want to take a Pico Mem or something like that and put that in there. But once again, same problem. The schematic is open source, I think. But actually, no. The firmware is open source, but the schematic and hardware, once again, is another one of those situations. I don't want to get into the politics of that on this video or this channel right now. But it's an unfortunate thing. So I'm going to have to go and redo the entire thing myself. Come up with my own design that has... Because I'd like to take a Pico Mem and a Pico Gus. Because the Pico Mem can do the storage emulation. And the Pico Gus can do the audio emulation. But again, it's also a 8086. It's basically a Turbo XT. So there's not a whole lot one can do there. But we get Wi-Fi emulation. So we can get on, like, you know, BBSs and stuff like that through Telnet. And of course we have net drive storage through the Brutman TCP/IP stack and little things like that. So that's cool. But anywho, that's gonna be it for this video. So if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.